YouTube and in Zoom. Very good afternoon to you all on behalf of the Department of Chemistry, Nesamony Memorial Christian College, and the International Environment Congress Association, Kanyakumari chapter. Today, this afternoon, we have in our midst the head of the Department of PG Chemistry from our college, from the Nesamony Memorial Christian College, and the fellow staff members, MSc Chemistry students from the college. In addition, we have the students from Anna University Regional Center also, along with
Good afternoon to one and all present here. It is my immense pleasure to introduce Dr. P. Raj Pandiyan, who is currently serving as an assistant professor in the Department of Chemistry at SRM University, Amaravati, Andhra Pradesh, India. Dr. Raj Pandiyan obtained his MSc in Analytical Chemistry from the University of Madras in 2009 and subsequently earned his PhD in Chemistry in 2014 from National Chongqing University, Taiwan, where he worked on surface-enhanced Raman spectroscopy under the guidance of Professor Is Yang. Doctoral studies, he gained nearly 7 years of postdoctoral research experience at internationally renowned institutions, including the University of Alabama at Birmingham, USA, University of Leipzig, Germany, and Xiamen University, China. His research during this period focused on advanced application of SERS in biology, electrochemistry, and microfluidics. Dr. Raj Pandiyan's research interests span analytical chemistry, surface-enhanced Raman spectroscopy, spectroelectrochemistry, microfluidics, 3D printing technology, and application in food, pharmaceutical, and environmental analysis. He has published over 40 research articles in leading international journals, including highly reputed publications such as Nature Review Materials, Chemical Reviews, Light Science and Application, Journal of American Chemical Society, Carbon, Lab on a Chip, and Analytical Chemistry. He is an active member and life fellow of several professional societies, including the Indian Chemical Society, Chemical Research Society of India, Indian Society of Analytical Scientists, and the Material Research Society of India. And he also serves the scientific community as a reviewer for numerous high-impact international journals. With his strong interdisciplinary expertise and international research experience, Dr. Raj Pandiyan continues to contribute significantly to the advancement of analytical chemistry and spectroscopic techniques. Let us warmly welcome Dr. P. Raj Pandiyan.
Thank you, Sharon, for the introduction. Good afternoon, everyone. First of all, I would like to thank Dr. Ginil Mon for this invitation. So, for another 30 to 40 minutes, I'm going to talk about Raman spectroscopy and its application in environmental analysis. So, my screen is visible. Is it?
Yes, sir.
Yeah. Okay.
Presentation is fully visible and your video is also visible.
Right. Right. So first, I would like to give the content. First few minutes, I will talk about the environmental concerns and missions of the Congress and real world evidences and issues with environmental pollution. And then I would like to talk about Raman spectroscopy and its applications in environmental analysis. I would also explain another modern technique called surface enhanced Raman spectroscopy. And finally, I will give a take home message. So, you may know the current world is facing so many problems, especially environmental issues. So, these are all some pressing issues. For example, climate change and global warming, that is one of the major threats we are facing now, and also water contamination. Nowadays, we are not able to drink water, whatever we are getting from the well or from the tap. Every home we got a water purifier, and almost everywhere we have a water tank. That means that we need to purify the water before we consume it. It means it is contaminated with so many things, and also soil degradation. And our soil is also contaminated with many chemicals and other issues. Air is also polluted. You may know many cities are suffering with air pollution and agrochemical and pesticide residues. So whatever food we are eating now, we are not sure whether it is pure or contaminated with some insecticides or pesticides residues. And of course, our water, river, lake, everything is contaminated by industrial discharges in many districts. And there are some another emerging contaminants, for example, microplastics and polyaromatic hydrocarbons. And many things are considered as emerging contaminants in this scenario. So, not only researchers are working on this issue, our government is also working, even our World Health Organization is also working to solve these issues or tackle these problems. For example, in India, different missions working for environmental sustainability, and we have so many schemes. So India's national action plan on climate change. Okay, one is regarding the climate change, and also we have many mission special project calls are there. For example, National Solar Mission, National Mission for Enhanced Energy Efficiency, National Mission for a Green India, and also we have Swachh Bharat Mission to have our environment clean and to clean the Ganga river. So the river is also polluted, and we are also focusing on sustainable agriculture. So in many directions, researchers as well as government and many national institutes are working on this direction. Okay. So along this direction, the International Environment Congress Association is also focusing on these issues or these things mainly. So educating younger generation in all fronts towards environmentally caring and healthy practices, and enriching the members, academicians, scientists to increase their personal and academic potential, also creating awareness not only in students and also in the public. So contribute in all possible ways. So what are all the core focus we have here? So one is promoting environmental awareness, and then encouraging sustainable solutions and supporting global research collaboration, providing scientific platform for knowledge exchange. So therefore we can actually bridge the gap in research and also industry, innovation and policy. Finally, we may have improved environmental decision making and stronger global research networks. So, how can we educate people? So, there are many ways to educate people. So, this seminar is also one of the ways to educate the younger generation, especially students. So, another, there are many ways. Community based environmental awareness programs can be conducted so that public can get knowledge about it. School and university sustainability curriculum integration. We can, of course, environmental science subject is compulsory for school students. Also for the university, we should have a compulsory course on this. And public workshops and hands-on training sessions can be conducted. Digital campaigns and social media outreach can also be done. Citizens science initiatives, collaboration with governmental agencies and non-governmental agencies, local governing bodies, industry academia outreach programs can be conducted, and also demonstration projects which can showcase the current technologies. Youth engagement through competitions, we can conduct competitions and challenges. Prize and awards can be given to the prize winners, and open access knowledge platform and webinars. These are all the things. So here you can see the impact of different pollution, how it is affecting the public and also environment. Okay, so environmental crisis in India, for example, in India, air pollution itself, the key impact is premature mortality. So estimated death affects approximately 1.7 million deaths. So why I'm showing here is why we have to focus on these issues. So these are all the problems. So we have to focus on these environmental issues or concerns. So extreme heat in 2024, heat-related mortality 219 plus deaths, and water contamination in India especially, many people died because of bacterial illness and also water contamination. Sewage and waste in Varkala 2026. So beach ecosystem harm, the environmental and public health concerns are there. Wildlife mortality, so not only human beings are affected, and also animals and other living organisms are also affected. And here you can see 11 deaths because pesticide poisoning. So not only in India, in other countries, developed countries also, in some sanctuaries, animals are dying just because of consuming toxic chemicals or pesticides. So here you can see 2.5 not only killed 1.7 million people in India during 2022, but also it caused financial losses. Okay, so 9.5% of country's GDP. So there are many issues related to it. Here you can see the problem with pesticides. Now farmers and we are using it intentionally and unintentionally without knowing the impact of pesticides and insecticides. So here we can see some incident. Okay, one is this pesticide poisoning. So the key outcome is hospitalization and impact. It was around 63 deaths. And this is another problem in Telangana, paraquat poisoning. Okay, 200 deaths per year. Then hospital poisoning, pesticide poisoning cases, high prevalence in adult poisoning cases, suicide by pesticide, and also wildlife pesticide incident there. So we have to pay attention, and government is also taking action on it. For example, some pesticides are banned. We cannot use those pesticides because it is considered as toxic. So Punjab High Court grants stay on ban of 12 pesticide molecules, and the European Union also banned pesticide trade expansion despite promises to end it. UP government, Uttar Pradesh bans the use of 11 pesticides which can damage rice. Sometimes we have to follow these rules and we should not use, but many times without knowing the seriousness, farmers are also using. So how can we stop this, or what are all the ways to address these issues? So now I'm going to talk about some analytical techniques. Okay, that means since you people are many are from chemistry, you can understand that analytical method means or technique means we use some instrument to detect the chemicals or biomolecules in different systems. For example, here we can see list of analytical techniques. One is coming in the spectroscopy. So spectroscopy means what? We use light to detect something or chemicals or compositions in a target system. So in this case, what I'm going to discuss is mainly Raman spectroscopy, surface enhanced Raman spectroscopy, And these are all some other spectroscopic techniques. For example, UV visible spectroscopy, FTIR, and also we have chromatographic techniques, gas chromatography, HPLC. So these are all some separation techniques. Apart from that, we have many other techniques which can have lab on a chip devices. That means microfluidic device, and also electrochemical methods like voltammetry, potentiometry, amperometry, and these are all some water quality analysis, and of course sensors where we can use biosensors also. So these modern environmental monitoring relies on a combination of analytical precision, portability, real-time sensing technologies. So in the next coming slides, I'm going to talk about mainly Raman spectroscopy and surface enhanced spectroscopy, how we can use these techniques to address the problems in our environment. First, we should understand what is the Raman. Raman, actually, Sir C.V. Raman is from India. So we can be proud that he discovered this technique in 1928. First time he experimentally proved what is inelastic scattering. So we have one is elastic scattering and another one is inelastic scattering. So Raman scattering is inelastic scattering of light. So what we can do, this means when we excite molecules using visible light, the scattered light can be collected and detected. So with that information, we can clearly tell what is the chemical structure, and also the fingerprint information can be provided by using Raman spectroscopy. Though the technique was discovered in 1928, like almost 40 years, Raman spectroscopy was not widely used because we did not have laser. So the sensitivity of the instrument was very less at that time. In the beginning, we didn't have microscope also during 1930s and 40s. So 1960s only, laser, we got lasers, and then many chemists started using Raman spectroscope so that bulk analysis can be done during 1970s. However, Raman spectroscopy was not, they could not use it for trace level analysis because the scattering process itself is a weak process. In 1974, Martin Fleischmann from University of Southampton, he discovered this particular technique called surface enhanced Raman spectroscopy. That means here we can use nanoparticles, gold or silver nanoparticles, and then we can easily detect trace level molecules using this technique. So this technique we call it as SERS nowadays. So this is called surface plasma or surface enhanced Raman spectroscope. So we are dealing with three components. One is laser, that is the source we are using to excite the molecules, and the nanoparticles, that is gold or silver. We are using it as nano amplifier that will amplify the signal. And molecule is nothing but a toxic chemical. It can be pesticide, it can be insecticide, or dyes, or some other toxic compounds, for example, microplastic. These things can be easily detected if we are using a nanoparticle and laser. Okay, that is SURF. So here we can explain two mechanisms. One is this electromagnetic mechanism and chemical enhancement. That means surface plasmon resonance. Because of that particular property, the Raman signals of the adsorbed molecules on these nanostructures can be greatly enhanced. So this is why we use gold and silver nanoparticles in surface enhanced Raman spectroscopy. So here we can see the history, how it started, when it started, and what are all the developments in this particular technique. In 18th century itself, we got IR spectroscopy. So, you know, IR spectroscopy and also Raman, both are called as vibrational spectroscopy or molecular spectroscopy. We can get chemical information, structural information, also fingerprint information about a variety of chemicals and biomolecules using this technique. In 1928, as a Raman effect was observed, and 1960 we got laser, and 1962 This is stimulated Raman spectroscopy, hyper Raman spectroscopy, and 1970s we got microscopy. In 1974, first SIR spectrum was observed, and 1977, a scientist explained the reason behind a SIRS, and this is surface plasmon mechanism, how the signals are enhanced. Confocal Raman microscopes we discovered or we introduced in 1990s, and then single molecule cells detection was done in 1997, and nowadays we have different techniques called TERS, shiners, and also we can do imaging as well as we can get Raman spectrum also. So this is how the technique evolved. First Raman 1928, and then SIRS, and now we have TERS, also shiners. These are all some modern techniques. Okay, so why SIRS can be considered as a next generation analytical technique or promising analytical technique? Why we have to use this for different fields? So these are all some advantages. Okay, one is negligible water interference. We will not get too much signal from water. So it's unlike IR spectroscopy. IR spectroscopy, you will have interference from water, also from carbon dioxide. But in Raman spectroscopy, we will not get much interference because water is a weak Raman scatter. And also it can provide wide spectral window. That means 400 to 4000 wave number, we can get the spectral information. So because of these advantages, we can use Raman spectroscopy for electrochemical studies. That means spectroelectrochemistry. Electrochemical reaction will occur in one side. Parallelly, Raman spectroscopy can be done. Another one is surface science. For surface science applications, we can use Raman spectroscopy because no need to prepare sample. So we don't need to make pellet. Whatever sample it is, it can be solid, liquid, or gas, we can keep under the microscope and we can measure Raman spectrum. In some cases, we can use it for non-destructive analysis. That means some analytical technique like mass spectrometry, it's a destructive technique. But Raman spectroscopy is non-destructive. That means after measurement, we can use the sample. Next is catalysis. We have different Raman spectrometers and also portable Raman spectrometers are available, and in situ monitoring can be done. If the reaction is going on parallelly, we can take Raman spectrum. So we can use for heterogeneous catalysis. And another important area is for biology because we can get sensitive and selectivity is also there. Fingerprint information we can obtain from biomolecules as well, bacteria, virus. Many biofluids can be detected using Raman spectroscopy. So due to these advantages, nowadays Raman spectroscopy is used in forensic analysis, homeland security, microfluidic devices, medicine and imaging, food safety, and in pharmaceutical analysis also we can use Raman and SIRS, spectroelectrochemistry, and energy devices, art and archaeology, and of course, environmental analysis. So this is why we are talking about this thing, and there are many applications so far. One is detecting biomolecules, environmental analysis, pharmaceutical analysis, food adulterants. If our food is contaminated with toxic compound, we can use SIRS or Raman to detect. Also, chemical agents in forensic, in crime scenes also, Raman spectroscopy can be used to detect healthcare, pathogen detection. So these are all the different applications for SIRS and also Raman spectrometer. When we see the instrument part, this is how in 1928 C.V. Raman used. This is the instrument he had at that time, as I said, no laser and no CCD detector, no Raman microscope. Without any sophisticated equipment, Sir C.V. Raman proved that inelastic inelastic scattering effect, the Raman effect. But nowadays, we have sophisticated analytical techniques, especially you can have microscope, and this is a fiber coupled portable Raman spectrometer, and we have handheld Raman spectrometer also. So with these different configurations, we can use Raman spectroscopy for environmental analysis and other chemical detection. So from the beginning, if you see, usually we have two different directions. So one is fundamental research and another one is this practical research or solving real world problems where we are focusing on food and drug analysis, environmental analysis, and bioanalysis. On another side, it's all about fundamental research where we are focusing mainly on the resolution part, okay, energetic resolution, spatial, and temporal. So these are all the primary directions. So here you can see search substrate. That means nanostructures. I told you silver and gold nanostructures are used for the search technique. These are all the different generations of search substrate. In 1970s, it was like this. Metal colloids were used, and we started using more uniform nanostructures, rigid search substrates, and nowadays we have flexible, transparent search substrates. These substrates can be used for some curved surfaces, real samples like fruits, vegetables, and also fish and meat where we can detect toxic chemicals. Okay, so this is how researchers are developing different dimensions or different 2D materials or three-dimensional materials and changing the analyte functional groups so that we can achieve ultra sensitive detection. And sometimes we can make hybrid materials also, for example, two-dimensional material and noble metal nanostructures. These can be combined, right? So far I have discussed about Raman spectroscopy and surface enhanced Raman spectroscopy. And this is our lab located at SRM University, Andhra Pradesh. So rare lab, that is Raman Research Lab. So from our lab, we are focusing mainly on food, bio, and environmental analysis. So I have almost 7 PhD students, and they are working on different research problems. So these are all some SEM images of the nanostructures we prepared. So I told you silver or gold. This is nano popcorn, nanostructures, and micro flowers. Silver and gold nanostructures have been prepared. So here you can see one of my PhD student. She is Arunima. She did this work. She is a PhD student. She prepared these silver nanopopcorns using a chemical method, and then we detected this toxic compound called nitrofuranate. This is an antibiotic mainly used for veterinary treatment. However, it is not legal. It's illegal. We should not use this particular chemical because it is banned. If we use this, what will happen if we still use and if we consume this thing? It is carcinogenic. Okay, so people will get cancer if they are regularly having or consuming these contaminated food products. So in this work, what we did, we first prepared these nanostructures nicely so you can clearly see how the nanostructures are. We optimized the condition using different volume of trisodium citrate, and also we modified the volume of nano popcorn. And then we could clearly see the signal from the chemicals. Okay, so with that, what we did, we tried to detect this nitrofurazone in normal water and also tap water and in honey water. So honey is also contaminated. If bees are consuming that particular antibiotic or nitrofurazone, then eventually whatever honey we are consuming is also contaminated. And then we detected the same antibiotic on fish surface. So if the fish is contaminated, we can use the Raman spectroscopy to detect whether the surface is clean or polluted. Okay. Another work, the same student, she prepared nanostructures on glove-like structure. So this is a glove, hand glove. On that we coated silver and mixing. So these two materials have been coated on this particular glove material, and then we can use this for sampling on vegetables or fruits. In this case, it's tomato. So we try to detect fipronil. Okay, that's the chemical that is not good for human health. So first we optimized the procedure. So here you can see SEM images of the nano popcorn and mixin, and then we systematically uh, characterize the substrate whether we are able to get signal from fipronil or not. Then we proved or we successfully developed the substrate. With that, we tried to detect the toxic compound fipronil on tomato as well as chili, green chili samples. So how these methods will be used? So for example, food industry can use this method. Our governmental bodies can use this analytical technique so that whenever these foods are contaminated with these chemicals, we can take action. Okay, either we have to stop that particular pesticide or the toxic chemical should not be used. So we don't know, we cannot detect all these pesticides by eyes. That's why we are developing such kind of Raman based analytical method so that we can detect these toxic chemicals on real world samples. In this case, one of my another PhD students, Jayashree, she used fish scale, and to detect PFAS, forever chemical. That means I'll tell you that is a polyfluorinated alkyl compounds. They are also toxic and it is everywhere. In this case, what we did, we used fish scale and then we coated nanoparticles on it, and then we optimized the preparation procedure. And finally, what we did, we use this particular substrate to detect PFAS, that is polyfluorinated sulfonamide samples. They are very toxic, especially when we use this fire extinguisher. These chemicals can be can contaminate water samples and also soil samples. In the US, United States of America, many military bases were contaminated with these chemicals. After identifying these chemicals in water samples and soil samples, those camps were moved from one place to another place because the contaminated soil and water will eventually affect the birth or also affect the military persons, whoever is working in that region. So it is important to check or examine the quality of soil and water. So wherever we are living, we have to check or the government should take action to ensure the water quality is good and also the soil quality, air quality. These things are important. In the next work here, you can see one of my PhD students, he developed a photochemical method to deposit silver nanoflakes on mixing. And then what he did, he tried to detect a dye called crystal violet in spinach. Okay, and another one is shrimp. So if shrimp or spinach is contaminated with this particular dye, then it is not good for our health. So in this work, what we did, we used Raman or search-based method to detect this particular toxic dye in food samples. So the detection limit was 10 power minus 10. That means even the concentration is very low. The concentration of the toxic compound is very low. We can easily detect using our method. So in the next few slides, I will just show some real world examples from some other group. So in this case, you can see surge detection of dye and insecticide. Dye on fish sample. So here you can clearly see the Raman spectra, and another one is the insecticide and pesticide on fruits. So you can clearly see without by Raman spectroscopy, these researchers successfully detected these toxic chemicals. And another one, residual pesticides in tea leaves. So whatever tea leaves we are using now, there will be quality control in that particular industry. However, from our side also, researchers and also governmental agencies should check the quality of tea and also coffee powder. In this case, what they did, tea powder was analyzed using Raman spectroscopy, and after spiking, they were realizing that in some cases, in some places, These tea leaves are also contaminated by these toxic compounds. So what else? So far I showed Raman spectroscopy or SERS can be used for chemical detection, pesticide detection. In this case, here you can see the different applications. One thing, if the sample, let's say water sample or soil sample is contaminated with nanomaterial, we can detect. And many places, this heavy metal contamination is also there. Because of this, public or people may get cancer, throat cancer in some areas. Heavy metal concentration is really high. So it is necessary to take action, and we have to make sure these people are not affected. And radioactive elements can be detected, pharmaceutical contaminants. If we are living near a hospital or some industry, and if they are releasing antibiotic, and if we are consuming, now the emerging problem is AMR, antimicrobial resistance. So these issues should be solved, and we have to continuously, carefully monitor the quality of water, soil, and air, industrial waste, and also microorganisms. These things can be detected using Raman spectroscopy and surface enhanced Raman spectroscopy. Here you can see list of water contaminants, and there is a maximum contamination level. Beyond that, it cannot be accepted. So this level is fixed by US Environmental Protection Agency. So these are all the different categories. For example, microorganisms, disinfectants, inorganic chemicals like cyanide, copper, arsenic, organic chemicals like benzene, toluene, chlorobenzene, uranium. So these are all the maximum contamination limit. Okay, it should be 0. 4 ppm for chlorine, a disinfectant, and cyanide, 200 ppb, benzene, toluene. What will happen if we consume water or contaminated food? These are all some long-term effect. For example, gastrointestinal illness, anemia, nervous system effect, liver and kidney issues will happen, eye, nose irritation, stomach discomfort, anemia, nerve damage, liver or kidney damage by inorganic chemicals. And because of organic chemicals, also decrease in blood platelets, increased risk of cancer, kidney and liver issue, increased risk of cancer if we are living in a contaminated area where we have uranium. So how we can detect all these things? These are all some possible ways. For example, Raman and FTA, Fourier transform infrared spectroscopy. These techniques can be used to monitor the contamination in our environment. So here you can see a field deployable source method to detect nanoparticles in environmental water. Okay, so this is a portable Raman spectrometer, and they used a vacuum membrane filtration, and the authors detected nanoparticles. That is also not good for our human health. The conclusion here we can see from invisible to identifiable. Even very low concentration of pollutants like pesticides, microplastics, and antibiotic can be detected using Raman and SERS. In our case, we say that prevention is better than cure. Hmm. Early detection is equal to prevention. So Raman spectroscopy enables identification of contamination before it escalates into major environmental or health crisis. So before that, we have to detect. So one technique, we can solve multiple threat. A single Raman platform can monitor different pollutants across water, soil, and food systems. And it is one towards real-time environmental safety. That means portable Raman spectrometers can pay way for on-site, rapid, and a reliable environmental monitoring. So here you can see field deployable Raman spectrometer where we can monitor the soil quality, and also plant diseases can be done like characterized using SERS and Raman techniques. So what are all the challenges in our field? In our field, producing those nanostructures, gold and silver, stable nanostructures. So now we have gold and silver, they are actually not stable. they are very reactive. It can be easily oxidized. So we researchers are trying to produce and prepare stable, sensitive nanostructures. Then these substrates can be used for food analysis, drug analysis, and also environmental analysis. So take home message: environmental pollution is often invisible. So we may think everything looks fine, we are happy, but it impacts are long lasting and severe. So we have to take action now itself. Early detection is the key to prevent environmental and public crisis. In this direction, Raman spectroscopy enables rapid and non-destructive identification of different pollutants. Even very low level contaminants in low concentration also we can detect. So integrating Raman can transform environmental protection from reactive control to proactive prevention. So with that, I would like to thank you for your attention, and I would like to thank my research group members also for their contribution. Thank you very much. I'm glad to answer your questions.
Thank you, sir. Thank you for that excellent presentation given. And now the session is open for discussion. I invite the participants to have your questions. It was very interesting, and I hope those students available might have got enormous ideas. Their ideas could have been ignited in various directions. I hope you will have a lot of doubts. Not that means your eagerness towards the topics he has presented. Uh, I request to the students, you can switch on your mic and ask your questions. Not just students alone, academicians also, teachers also, you can go forward. So, let me start with. Sir, hope you are hearing me. Can you hear me?
Yeah, please tell me.
I'll ask my question on behalf of my students, MSc Chemistry students. The scope for PG Chemistry students in Raman spectroscopy or using Raman spectroscopy towards environment applications or in research, what is maybe in another 2-3 years, what will be the scope and what are the possibilities, their opportunities? If you can give you an overview, it will be more than good for our students.
So Raman spectroscopy, especially in this case, students, if they are good in handling these instruments, they can get job in pharma company and also chemical industries. That is one option. Another option, they can directly get into the companies who are making Raman spectrometers. That is one direction. And another direction, they can do research on Raman spectroscopy, PhD, and they can be professor and scientist after getting PhD. So there are many opportunities. Not only in Raman, in any analytical technique they can work.
Thank you, sir. Thank you very much for that. Right. And anyone else ready with your questions? The session was really
Right,
interesting.
sir, thank you,
Yes.
Dr. Rajan Pandiyan. It's a wonderful slides, nicely arranged. So it was very helpful for my students to understand the Raman spectroscopy, the in-depth analysis of Raman spectroscopy for the various environmental related problems.
Okay, thank you.
And wonderful. We are so happy to know that someone is working on the environment related with respect to the Raman spectroscopy.
Okay.
We've been utilizing this Raman spectroscopy for the material evaluation, right? Raman spectroscopy.
Yes.
A true application lies in the environmental sciences. I'm so happy to hear that. I'm so happy to be part of this conference. Thank you so much for your contribution, sir.
Thank you
very much.
Pleasure.
Nice. Thank
Actually,
you, sir. Thank you, Vinay. Thank you, Dr.
Thank you, sir. Thank you, sir. Thank you. Dr. Rajashekhar is the secretary of this association.
Oh, good.
And yeah, he was the one who suggested this first event to
I
be
see.
arranged in this manner. Anyway,
Okay.
So I wanted to initiate a monthly talk series.
Yeah.
So first, it's successfully we are done
Okay.
with that
Okay. Good.
talk series. Anyway, we'll carry forward, sir. With all your help, we'll just carry forward
Sure.
the work and all.
and
Right?
we
And
also
are you doing any projects under this now, sir? You have any projects related to the
Yes.
environmental science now?
Now my students are working on different projects. So 1 or 2 is related to this water.
Oh, okay. So you have a tool. You have the Raman SRES.
Yes, we have Raman instrument in our lab.
How much it comes on the handheld and all? Almost it comes around 20-25 lakhs.
Yes, handheld will come around 20. Another portable one will come around 30 to 40 lakhs.
30 to 40 lakhs. Okay. Nice.
actually Dr. Muthurulan told me that he's been Raja Pandiyan sir has been working on Raman ever since his MSc.
Yeah. Known him for almost 15 years, 16 years.
He was very much fond of. Is it that you are fond of Raman spectroscopy? What made you to take up this topic?
Oh, actually, I was interested in spectroscopy in general because I was interested to work in a pharma company. So I was applying for different analytical instruments positions. Fortunately, I got the PhD position in spectroscopy, ground spectroscopy lab. Then the thing started from there. After that, last 10 years, 15 years almost, completely working on Raman and source.
Okay. Wonderful, sir. Sir, and if there is a possibility of collaboration, are you open to the collaboration?
Yes, we are always open. We can, of course, do. Maybe you can write in detail in email what kind of project.
Yes.
And we can write.
Yeah, initially, let's say starts with the. Are you charging for the Raman analysis? It's okay to just send, right?
Yeah, we generally charge. If it is a collaborative project, we can think about some other option also.
Yeah.
We are planning to publish papers and all those things.
Yeah.
We will find some.
So either the publication works or some other collaboration also possible.
Yeah, that's fine.
I will keep in touch with you, sir.
Yeah, sure. Please contact.
Can I have your number, sir? Can I have your number?
Yeah, sure.
Yes, just read it for me.
Yeah, 7200
7200
641
641
221
33
221
22
221. And you can also get from
Sir, I'll share it. I have it with me.
Yes, I got it. 7200 641 221.
Yes, 64122.
Yes. Dr. Raja Pandiyan. I'll save it, sir. I will just ping on you, right?
Sure.
Thank you so much. Nice talk, sir. I spent a nice time with you.
Okay.
Thank you so much for the talk.
Hello.
Thank you. Is there any questions?
Someone is asking some questions.
Yeah, Dr. Santanu from you. Sir, you can speak.
So, Dr. Mohan, how are you?
Fine, sir. Fine. Hope you're also fine.
I see. Okay. So, Dr. Raja.
Yeah.
So your name is too big. Has not been able to pronounce
Raja
it.
is fine. Yeah, that's a very
So great. So I learned so many things out of your talk. It's a really nice talk. And you are working exactly along to our directions as well. So several of our papers already published on these directions, and we have been working on this as well. So many new things I saw. It's good. Just as for my understanding, what is the role of MO2C? Some of the structure you showed that MO2C you adopted, and for CRS purpose, but MO2C is kind of molycarbide, right? It's not plasmonics.
Yeah.
So what is its role on this plasmonic enhancement of this ACRS?
So you are asking a role of plasmonic nanomaterials?
No, MO2C,
Okay.
molybdenum
Okay.
carbide,
Molecule
nanoparticles.
Right.
So
Okay, so now, now I got it. In that work, what we are trying is plasmonic nanomaterials. Mostly they give enhancement because of the surface plasmon presence,
that's
electromagnetic
true.
enhancement. Now these two-dimensional materials, why we are trying is to increase the chemical enhancement. That means our analyte may interact with these materials strongly, so that we can also have additional sensitivity. That means enhancement. Graphene,
Yeah,
metal
I've not been
oxide.
able
So
to
now
hear
research
your
is,
voice actually.
yeah.
There's some sort of issues on the communication. So you said that MO2C is basically used as a plasmonic nanoparticle or as
No,
a dielectric
no
based?
plasmonic. It's like how to say. We assumed that, like, we thought that it may have some chemical interaction with it. That plasmonic effect is from gold and silver only. So
Ah,
we are using two materials. One is mainly for plasmonic, another one is for one high surface area or chemical interaction. Chemical interaction means
that's
that
true.
will
That's true.
bring the analyte close to the surface.
Okay.
Yeah.
So I've not been able to understand it because there's some noise problem. Maybe
Yeah,
I can
maybe.
interact with you later.
Sure.
Sometimes
Yeah,
because
we can.
this looks interesting to me. So if there is any possible that you are interested in collaborating, then we can think of. Okay.
Sure. You please contact me. We can.
So we basically do not sense with this kind of pesticides. We basically do all medical unit like dopamine and then oxytocin, and then this
Okay,
for nervous hormone for human body.
I see. Okay, it's interesting.
So
Then you
we
please
we
contact
we, we
that.
did we did many works on this. We have if I got your email ID, I can share a couple of our paper so you can
Yeah,
see.
please,
And
you can get from.
definitely, it's a very good talk. And I understand you only do ACRS, but I do many things: nanostructure development, ACRS, energy
Right.
generation, so many
Yeah,
things.
you please send me an email or a WhatsApp also. We can
Yeah,
think about some
but your
collaboration.
talk is very informative and a lot of new things because nowadays
Okay,
we are very
thank you.
busy in administrative job, so
Uh-huh.
barely have time to read the review paper or so. I do really appreciate that you bring all this all together.
Okay, thank you.
Nice, thank you so much.
Thank you.
Okay, thank you, Dr. Santano, for that live interaction. And Dr. Santano is an associate professor in the Department of Ceramic Engineering from IIT BHU. He's an honorary member of our association.
Okay.
And I thank you for that interaction. Thank you, Rajapandian
Yeah,
sir, and
so
thank you, Santano.
if you guys got chance, you can visit us, okay? In IIT
Sure.
Varanasi. If you are interested to visit Varanasi, just drop me a message that I want to visit. I will be happy to be a host here.
Sure. We will see maybe in future.
Okay.
Okay.
Thank you for
All
that
right.
offer. Thank you, sir. So, is there any other questions, friends? Hope most of the students have left. Only a few of the researchers and academicians are there. And anyway, thank you, Rajapandian sir, for that very interesting 1 hour. It was really informative. Your slides were very attractive. Hopefully, those gave a clear picture about what you are mentioning and what you are explaining. We are really happy to have you in our midst. And on behalf of all the members of the Environment Congress Association, I invite you to be a member of our association. I'll send you the link. You can just go through and just give your support for the association.
Okay.
And this is our actually, you are the first. This is our first activity after the inauguration.
Okay. Fine.
Anyway, thank you. Thank you for that great support and for the presentation. Thank you, participants, for your presence today. Hope to see you all in our next talk series, monthly expert talk series, and for all
Thank
our
you, sir.
future endeavors. Thank you, one and all.
Thank you.
Thank you, Raj. Thank you, Raja. Sir.
Thank
Thank
you.
you, sir.
Thank you, friends. That was a